The subject of this lecture is momentum. When we studied Newton's laws, we found out that it's harder to get a more massive object moving from rest than a less massive object. And this concept was related to inertia. We also know intuitively that for two objects moving with the same speed, the more massive object will be the harder one to stop. That means that we need to add a new concept to our understanding of physics and, in general, the world around us that addresses the question of how hard would it be to stop an object, or how hard would it be to make an object move. We need to find a concept that relates the applied force to the speed of motion of an object and its mass somehow. And so this new concept is momentum, and the related concept to that of impulse of a force. And so in this chapter, I'm going to discuss momentum and consequently impulse of a force and the various relationships they have and consequences to how objects move. Let's start with the definition of linear momentum. The linear momentum of an object P is defined as the product of its mass m and its velocity v. As you can see in this definition, we have included the mass, which then means that the inertia of the object as far as calculating the momentum plays a big role. And also we have included the velocity of motion, which means that momentum is a vector quantity since velocity is a vector quantity. And so momentum depends on the mass. So it's related to the inertia of an object. And momentum also depends on the velocity. And so, as such, it's a vector quantity. The momentum of a moving object has the same direction as a vector as the velocity of the object. The formula for momentum is P is equal to m times v. The units in which momentum is measured will be the units of mass times the units of velocity. So this is kilograms times meters per second. So from the units here, you see that when you're calculating momentum, you must convert the mass of the object to kilograms and the velocity of the object to meters per second. So if the mass is given in any other units, grams, tons, or something else, you convert in kilograms. And then if the velocity is given in other units, such as kilometers per hour or something else, you must convert to meters per second. So for future reference, I will refer to the momentum of an object that is moving along, in general, a straight line as simply the momentum. So the term linear momentum is used to indicate the motion that is not along a circular trajectory. However, I'm going to just use the word momentum for that type of motion. Later, when we talk about rotational motion, I will discuss a similar quantity, which is termed angular momentum, and I will use the full name for that quantity. So when I talk about momentum, I mean momentum of an object that is moving in a linear fashion. Now, if you look at the definition of momentum, mass times velocity, you can tell that the same momentum can be calculated for an object that has very large mass and very small velocity, as for an object that has a very small mass and very large velocity. Intuitively, we would think that an object that is moving with very large velocity would have very large momentum, and this is true, but it's not so intuitive to have an object that is moving very slow, but it has a very large mass as an object that has large momentum. And this is purely because visually the object is barely moving. However, if you imagine a large passenger airplane, moving on the runway, getting ready to take off, but before it starts to accelerate, you will think that the momentum of this airplane is small. However, because of the giant mass of this airplane, its momentum is actually pretty large. So, an object with very large mass moving slow can possess a pretty big momentum. Let's do one simple example of the application of the definition of momentum. Find the momentum of a 350 gram steel block sliding on a flat surface with velocity of 5 kilometers per hour. So we know the mass of the block, 350 grams, and we also know the velocity of the block, v, 5 kilometers per hour. What we are looking for is the momentum of the block. So we know that momentum is the product of mass and velocity. However, the units for momentum from the previous slide were defined as kilograms meters per second. And as you can see, the mass is in units of grams and the velocity in units of kilometers per hour, which means that we must convert those in the correct units before we do the calculation. So let's convert the mass first. So the mass is 350 grams, which is equal to 0.35 kilograms. For the velocity, we have 5 kilometers per hour, and we must multiply this by two conversion factors, one to convert kilometers to meters, and the other one to convert hours into seconds. So we have 1,000 meters per 1 kilometer, and then we have 1 hour per 3,600 seconds. And so the units of kilometers will cancel out, the units for hours will cancel out, and the result here is 1.4 meters per second. Now we can calculate the momentum of this block. The momentum is 0.35 kilograms times 1.4 meters per second. This is equal to 0.5 kilograms meters per second.